Hello everyone, welcome back to Unfog with Dr. Athar Parveen. Till now we have finished 3 parts of optics based on HSTR and KREIS syllabus. In first 2 parts we finished mirrors and lenses along with reflection and refraction, and then again in third part we discussed all about dispersion of light, total internal reflection, and optical instruments with simple and compound microscope and telescope. And this is the fourth part of the optics lecture, and in this lecture I am going to discuss theories of light. They are the Newton's corpuscular theory, Huygen's wave theory, Maxwell's electromagnetic wave theory, Max Planck's quantum theory, and dual nature of light. There is another theory which is Raman effect. I am going to cover this part, the Raman effect part, in the polarization part. Okay, so I will make one more video. This is the fourth lecture of optics, right? I am going to make the fifth part also. In that part I will discuss the Raman effect and the polarization. Okay, so today's lecture is based on these theories of light: the Newton's corpuscular theory, Huygen's wave theory, Maxwell's electromagnetic wave theory, Max Planck's quantum theory, and dual nature of light. Okay, before starting I would like to remind you all to please subscribe to my channel if you have not subscribed yet, and also please do like and share my videos if you like my work. Okay, and also we have a Telegram channel. You can join the Telegram channel. We have a discussion group also for HSTR and KREIS and all the teacher vacancy exams. We keep on discussing there, and I also keep sharing things there in that group. Okay, one more thing I want to remind you is, please watch the first 3 parts of the optics. Okay, I will give the link in the description. It will be better if you watch it along with this part. Okay, either before this part or after this part, it is your wish, but it is better you watch all the parts of optics, because then only you will feel connected with the chapter. Okay, there will be links between each part. I cannot complete the whole chapter in one lecture, right? It will be too lengthy and you also will get bored and you all will also get tired. So I make parts of each chapter and then I upload it in this channel, in my YouTube channel. Okay, I will give the link of the other 3 parts of optics in the description. Please do watch them, don't forget to watch. And also I have finished much of the HSTR portion from physics. I will give the link of the HSTR playlist. So please you try to finish the portion how much I have completed. It will be great if you go along with me. Okay, so let's start this lecture then. Firstly, let's talk about the Newton's corpuscular theory. Of course, this theory was given by Newton, and he explained this theory in order to explain the property of light. Basically, this corpuscular theory, it explained that light is made from small and extremely very light particles. Those particles were named as corpuscles. Okay, Newton named those small and extremely light particles as corpuscles. I have put a diagram here. You can see how light is spread according to Newton. It is spread as particles. When these particles, they travel in straight line and they hit the retina of our eye, then they produce image of the object which we are seeing. Okay, this image of the object, it can be seen by us because that light which is falling on our retina, it will produce the sensation of vision. Okay, this is what Newton told. Basically, this is the summary of Newton's corpuscular theory. But he gave little more details about that light also. For example, he told that these corpuscles or these particles of light, they are emitted from luminous sources. What are the luminous sources? Sun, it is a luminous source. It is a natural luminous source. Candle, electric lamp, etc. All the sources which emit light. From the sources, the corpuscles are emitted, Newton told. Then the corpuscles which are emitted, means the light which is emitted, in that light you have these particles, right, which we call as corpuscles now, according to Newton's corpuscular theory. These corpuscles, they can be of different sizes. And interesting thing is, he told that they are perfectly elastic and they travel at a high velocity. See, he gave indication that these corpuscles travel at a high velocity, but he didn't tell the value. Next is he told that this corpuscle or each particle, it will carry kinetic energy while it is moving. See how smart Newton was, right? During his time, nothing was there. Literally, he was in the olden days, right? The olden age. Then only he told that the corpuscles, they carry kinetic energy when they are moving. Great. Then he told that the different colors of light, they are due to different sizes of the corpuscles. Now here I want to remind you all that please watch the electromagnetic radiation lectures. I have made 3 lectures on electromagnetic radiation. I'll give the link of that chapter also in the description. So please go and watch it. If you have attended that class, you will be clearly knowing that the different colors of light means they are different wavelengths or frequencies, isn't it? But that theory came later. We will talk about electromagnetic theory also in this lecture only. This was the very first theory, the Newton's corpuscular theory. Very first theory which was given by Newton, and it was talking about the light. So here velocity of light and wavelength, frequency, all the terms have not come into picture still. Okay, this is just a starting research of light. Okay, so this was all about this theory given by Newton. But this theory, it had to fail. We know it because by now we came to know by the assumptions only that it is not possible that this thing, different colors of light, they are due to different sizes of corpuscles. All that is not possible, right? There are many more things which Newton told actually in corpuscular theory, and because of those things only this theory failed. Like for example, now first is the Newton assumed that light travels faster in denser medium than in rarer medium. Now this has been proved wrong, right? We know that the light travels faster in rarer medium and it becomes slow when it enters the denser medium. If you have attended the optics part 2, then you will know it very nicely. So this was one of the point because of which the Newton's theory, the corpuscular theory, was failed. There are many more things like he assumed that different colors of light are due to differences in sizes of corpuscles, right? But this has no justification. That colors are because of this wavelengths, right? Change in wavelength means change in color. That concept is not told here. Then he assumed that reflection of light, it is due to repulsion between the corpuscles and reflecting surface, while refraction of light, it is due to attraction between corpuscles and refracting surface. This is also not possible, right? The medium or the surface, it has nothing to do with reflection and refraction, right? So this also one of the point because of which the Newton's corpuscular theory failed. Now conclusion of this statement will be that the medium should either attract or repel the corpuscles of light. But this is not possible, right? This statement also, it was proved wrong. The medium, it has nothing to do with attraction or repulsion of light. Medium has nothing to do with light first of all. Okay, any medium is there, the speed of the light will change. If it is denser, it will become slower. If it is rarer, it will become faster. That's all. We have learned that only, right? See in this figure, you can see that incident corpuscles, they will be incident on the surface and then they will reflect. That's all. That surface, it has nothing to do with the light. It will neither attract nor it will repel. So this statement also was wrong. Then corpuscular theory, it could not explain phenomenon of diffraction, interference and polarization of light. Obviously, the assumptions it was making was only wrong. The base was only wrong. Then how could it prove diffraction, interference and polarization of light? So this Newton's corpuscular theory, it failed in explaining few important phenomena, the diffraction, interference and polarization of light. These are the main properties of light, right? We need to explain them if you are giving a theory. So this was all about this theory. Now let us see a few questions. Actually in this lecture I am going to solve more than 20 questions based on just the theories of light. So please do watch this lecture carefully until the end, because many expected questions I am going to discuss here, and I am sure that any question will come in HSTR or KREIS will be from this lecture only. Okay. So let us start with the question. First question is, Newton postulated his corpuscular theory on the basis of Newton's rings, colors of thin films, rectilinear propagation of light, dispersion of white light. See, Newton, he gave corpuscular theory. He told that there are some particles in the light, right? And they are moving in a straight line. So you can say that it is rectilinear propagation of light. Rectilinear propagation of light means light is moving in a straight line. Then according to Newton's theory, the velocity of light is, according to Newton's theory, not what is actually happening. Actually, the velocity of light is more in rarer medium. Okay, but Newton, he told that it is more in denser medium, which is wrong, but then he told it. So answer for this question is that it is more in denser medium, but actually the velocity of light is more in rarer medium. Okay. Next question. The theory of light, according to which the light is a stream of particles. They have given 4 theories of light. Which is the theory of light which says that light is a stream of particles? Of course, it is Newton's corpuscular theory. Next, they can ask this type of a question also. According to Newton's theory of light, the reflection and refractions of light are explained on the basis of. The options are repulsion and attraction of the corpuscles by the medium, construction of secondary wavelets, both of these, all of these. According to Newton's law of theory, he told that reflection and refraction, they are happening because of repulsion and attraction, right? But this is not right. But anyway, this is the right answer for this question. Okay, option 1 will be the right answer. Next question. The phenomenon of light which were not explained by the Newton's theory of light are. He could not explain all these: polarization, interference, diffraction. So option 4, all of these will be the right answer. Next question. The phenomena of light which were explained by both Newton's theory and Huygen's theory are. See, Huygen's theory I am going to teach now. I have not done it still, but I put it here because we are talking about Newton's theory also, right? Phenomenon of light which was explained by both Newton's theory and Huygen's theory are reflection and refraction. But then Newton explained it in a different way. His explanation was wrong. Regarding Huygen, we will know it now. Okay. But both of them, they explained about reflection and refraction. Next question. The scientist who made the first scientific attempt to explain the nature of light was, of course, it was the great Newton. Next question. According to Newton, light consists of, yes, it consists of tiny, light and perfectly elastic properties, right? These were all his assumptions. So option 1 will be the right answer. Next question. The first theory of light which explained the nature of light is, of course, it is Newton's corpuscular theory of light. See, I am giving you all the expected questions. Don't think that I am giving same type of repeated questions. These are all the expected questions. Any question can be asked in your exam. See, if they ask anything from Newton's corpuscular theory, that will be from this lecture only. So much assurance I can give you, okay? Because I make these lectures with lots and lots of research. So you can trust me and you just follow my lectures for physics, okay? Then 10th question. According to Newton's corpuscular theory of light, the various colors of light are due to difference in sizes, right? He told that the size of the corpuscles are different, so their color is also different. That is wrong, but it was his assumption. So this is the right answer for this question, okay? Now let's talk about the Huygens wave theory. See, by now Newton established the concept that light is made up of tiny, extremely small light particles. So much concept was made. But Huygen, he did not believe his theory. He told that every point that a luminous disturbance meets turns into a source of the spherical wave itself. The sum of the secondary waves, which are the result of the disturbance, determines what form of the new wave will take. This theory of light is known as Huygens principle. See, don't worry, it was a very big statement, right? I will explain you what it is. Firstly, let us know the year. In 1678, Huygen proposed this theory. It is known as the Huygens principle. See, what he told was simple. You must have seen water, right? If you throw a stone in water, what are the type of waves which are formed in the water? They look like this, right? Now, if I want to give you a moving picture, it will be like this. It will be like this, right? So, what is happening? When you throw the stone will make first wave. That first wave will lead to the second wave. that second wave will lead to the third wave, isn't it? So the first point was your stone, that is your source. Okay, you think that water has a light now. That stone is a source now, which is making one spherical wave. Now this spherical wave, it is the reason for the formation of secondary wave. That's why second wave is forming, right? That is what he is telling. The sum of the secondary waves, which are the result of the disturbance, determines what form the new wave will take. Okay, it is spherical only. For sure it is spherical, because the stone, the first wave is spherical, so second wave is also spherical. In case if that first wave was square, then that second wave would have been square, but that is not possible, right? So this is Huygens wave theory. Now I am giving an example of water. The same example you take it for light. In place of water you take light. This is your Huygens principle. I hope you understood. Next, he told that all this is happening in one medium. That medium is only ether. This is where he went wrong. Okay, the medium he told is ether. Now this Huygens principle was one of a kind in itself, because till now all were telling that light is having particles, right? Huygens told that it is like a wave. With this principle he derived laws of reflection and refraction. So we will have to believe him, right? Then he also explained that the linear and spherical propagation of light is happening. Means light can be moving in a straight line, or it can be a spherical form if the wave is spherical. All this he told based on this theory only. But at that time, no, he was not able to explain diffraction. He explained reflection and refraction, but he could not explain diffraction at that time. But using his theory only later, Thomas Young in 1803, after more than 1.5 century, Thomas Young, there is a famous Young's double slit experiment. He showed that it is possible. The interference or the diffraction is possible using wave theory of light. The Huygens wave theory of light. See, this is interference. If you have two slits and if you are passing light through that two slits, or if you are lighting a candle there, the light will pass through those two slits. Actually, we have one source of light, that is candle. But because light is passing through two slits or two holes, that will, two holes, they will behave as two sources again. That is what Huygens told, right? That will behave as two sources again. Then you will have this bright and dark fringes on the screen. This is what Young's double slit experiment is, and it is based on Huygens wave theory of light. Then Maxwell came into the picture. Maxwell, he also had his own electromagnetic wave theory. He told that electromagnetic radiation is there. It is a form of energy, but it is produced by movement of electrically charged particles traveling through a matter or vacuum, or by oscillating magnetic and electric disturbance. We did all this in electromagnetic radiation chapter, right? I will give you a glance here. I will give you a brief gist based on Maxwell's electromagnetic wave theory. But if you want to know, have all clear picture, if you want to have, then you please watch those lectures, the electromagnetic radiation lectures. I will give the link in the description, okay? And he further explained that this magnetic and electric fields, they are perpendicular to each other. They combine together and they are oscillating fields with which the disturbance occurs, and they are perpendicular to each other. Means the electric and magnetic fields, they are perpendicular to each other. And this electromagnetic radiation, he told that it occurs when an atomic particle like an electron is accelerated by an electric field, causing it to accelerate. Means that electron is the reason because of which this electromagnetic radiation is occurring. Actually, before electromagnetic theory came into picture, people thought that magnetism and electricity, they were two separate forces. But Clerk Maxwell, who gave this electromagnetic theory, he unified this theory. He told that magnetism and electricity, they work together also. Magnetic poles, they come in pairs, he told. They repel and attract each other. Just like electric charges also attract and repel. No? In the same way, magnetic poles also attract and repel, he told. Then electric field, when it is in motion, it will produce magnetic field. He told all this. Okay. Then a wire with an electric current, it will produce a magnetic field whose direction depends on the direction of the electric current. That is what we are talking, right? So all this was told by electromagnetic theory. Then he also described that wave. He told that this electromagnetic radiation, which consists of magnetic and electric fields, they travel perpendicular to each other and they have few characteristics like wavelength, amplitude and frequency. Then he told that these electromagnetic radiations, they can travel through empty space. Then waves other than electromagnetic waves, they have to travel through some substance. For example, sound, it cannot travel through empty space, right? It needs some medium. But it is not like that for light. It can travel through vacuum also, he told. Then he specifically he told that speed of light is 3 into 10 to the power 8 meter per second and it is always constant. So this was all about Maxwell's electromagnetic wave theory. I combined Huygen's theory and electromagnetic wave theory because both were talking about the wave theory, right? They told that the light is wave, but then both have their different description and Maxwell's was little bit developed theory. He gave more information. So I combined. Now let's see the questions based on these. The theory of light which explained the phenomena of light such as interference, diffraction and polarization is, of course, it is Huygens theory. The theory which assumes or which proposed that light travels in form of waves from a source is actually Huygens theory and Maxwell's electromagnetic theory, but we will take Huygens theory because this was the theory which told first time that light is a form of a wave. Okay. Next question. The Huygens theory of light assumes that light travels in the form of a wave. According to Huygens wave theory, the reflection and refractions of light are explained by the construction of secondary wavelets. Okay, why construction of secondary wavelets? I told you, right? The first wave will lead to the second wave. The second wave will lead to the third wave. Means here secondary waves are constructed, isn't it? So this was the concept given by Huygens wave theory. Next question is, according to Huygen, the medium required for the propagation of light is, he told it is ether, right? But that is just one assumption. That's not true. Now Max Planck came into picture. He is the real hero, I feel, because the things he told no one can imagine. Max Planck. It is told as quantum theory also because it was a modern theory. The main points of this Planck's quantum theory are: radiation energy could not emit or absorb consistently, but it could emit or absorb in discrete quantities. These small bundles of energy are called quanta. In terms of light, these bundles are referred as photons. See, maybe if you are watching my lecture for the first time, maybe you will feel strange now because you will feel that I am just reading these lines. But this is not true, friends. We have explained everything in electromagnetic radiation chapter. That's why I am not spending much time here. Okay, I will just give you one summary. Max Planck told that there will be some discrete quantities of energy which will be absorbed or emitted. There will not be any fraction. There will be only whole numbers. And this light will come into some small bundles. Those bundles are known as quanta. Okay. And these bundles, usually we call them as photon also. Okay. So if someone is talking about photon, it is understood that he or she is talking about light. Then he told that the energy of this quanta, it is proportional to frequency. Means E is proportional to nu. And if I remove the proportionality constant, I will include a constant h, which is known as Planck's constant, and frequency is inversely proportional to wavelength. That's why either E is equals to h nu or E is equals to h by lambda. But then we will also include the speed of light because frequency is equal to c by lambda. Okay. Again, I would like to stress, please watch electromagnetic radiation chapter lectures. That will be very, very helpful for you all to understand this lecture. Okay. Next, third point which Planck told is that the total amount of energy emitted or absorbed by any particle, it is integral multiple of h nu. That only in discrete quantities I told, right? Means n h nu, E will be equal to n h nu. This n is a whole number. It cannot be a fraction. These are all the points of Max Planck's quantum theory. Now, till now everything was clear, right? Newton told that light consists of particles. Then Huygen and Maxwell told that light is a form of a wave. And Max Planck told that no, light is having energy that is in the form of bundles of energy or quanta. We tell them as photons. He also told how much energy is there, that is equals to h nu or hc by lambda. That also he told. Also he told that energy, it will not be in fractions, it will be in discrete multiples or integral multiples. Means it will be 1 h nu, 2 h nu, 3 h nu, 4 h nu, like that. It will not be half h nu. It will be whole numbers only. Okay. All this clarity Max Planck gave. In that time, one more thing came, the photoelectric effect. This was explained by Einstein. We have discussed this also in electromagnetic radiation chapter. I will not discuss it here because it is not there in the portion here. Just I am giving you one glance that photoelectric effect means if one light is incident on a metal, that electron will be ejected out. It will behave like a particle. Now, photoelectric effect told that light consists of particles. Again, it is behaving like a particle. Means it failed wave theory of light again. He told that light has a particle nature. Now people got confused. Does light has only particle nature or light is a wave? We don't know, right? Because few people told it is a wave, few people told it is a particle. But what is light? Particle or wave? Then the modern answer for this question is that light has both wave nature and particle nature. It will behave more like a wave and less like a particle sometimes, and sometimes it will behave more like a particle and less like a wave. So the moral of the story is that light, it will travel as a wave and it will hit like a particle. So this gives the dual nature of light. This is the modern answer to what is light. This dual nature of light, it was explained by the Prince Louis de Broglie. Actually, he told that if wave is behaving like a particle, then particle should behave like a wave. He got Nobel Prize for this concept also. In 1929, he was given the Nobel Prize. Actually, it was his PhD thesis where he told that wave nature of matter is also there. If wave is behaving like a particle, particle will also behave like a wave. But then why we are all not moving like a wave? Because that is related to this formula, the wave nature of light, momentum h upon lambda. How much small that particle will be, so much nicely that wave behavior can be seen. Means electron, you can see the wave behavior. But we are big particles, right? So we have so less wavelength. So though we are moving like a wave, we cannot be noticed that we are moving like a wave. This is the concept of dual nature of light or wave nature of matter. Okay. This lambda is equals to h upon p. See, momentum will be more if the particle, if that wave is behaving like a particle. Wavelength will be more if that particle is behaving like a wave. Because wavelength is the property of a wave, right? Momentum, it is the property of a particle, right? If the car is moving, find the momentum, we say. The wave is moving, find the wavelength, we say. So, wave-particle duality, he told that nature is symmetrical. If wave is behaving like a particle, then particle is behaving like a wave. Okay. Now we will have questions based on this. Quantum theory of radiation was proposed by, yes, it was proposed by Max Planck in year 1900. You should know the year also, very, very important. De Broglie equation states the dual nature. Evidence of the wave nature of light cannot be obtained from reflection. Why? Because reflection phenomenon is shown by both particle and wave nature of light. So we cannot say that light is just a wave. The reflection is shown by particles also. The modern quantum theory attributed the following to light for complete understanding of various phenomena exhibited by light. It is both particle and wave nature. Means modern quantum theory means dual nature only, you remember, okay? The theory according to which light is treated as consisting of quanta of radiation called photons is, it is modern quantum theory or Max Planck's quantum theory. The wave theory of light does not explain photocurrent because photoelectric effect explains photocurrent and photoelectric effect talks about the particle nature of light. The momentum of a photon of wavelength lambda is, of course, it is hc by lambda. The quanta of radiation are called, yes, they are photons, okay. So this was all about your theories of light. Raman effect is remaining. I will explain it in the next lecture. But for instance, very important thing I want to remind you all is, please watch electromagnetic lectures, all the 3 parts. I will give the link in the description. Their thumbnails, they look like this. Okay. Why I am insisting again and again? Because I have not explained photoelectric effect and electromagnetic radiation in this class again. The electromagnetic radiation theory, the Maxwell's theory. Why I did not explain means already I have explained it there. No, that's why. Okay. Please go and watch this 3 lectures also. Okay. Along with optics lectures. Now, assignment question for you all. You have to answer the question according to corpuscular theory of light. The rectilinear propagation of light is explained by the 4 options are there. You have to give me the answers in the comment section. Okay, friends. I hope that I really helped you all and please watch the lecture sincerely. See, my first lecture of HSTR lecture series was electronics, first lecture. More than 3,500 people have watched it. But nowadays HSTR lectures, they are not at all watching. Only 600 or 700 people have watched optics lecture. And I don't think the optics lecture, I think so many people have also not watched. Only some 200 or 300 people have watched it. This is really very demotivating, friends. Please don't do that. You watch all the lectures till the ends and you learn. I am making this lectures for you all, right? You will gain knowledge by watching these lectures and it will be helpful for you all in clearing HSTR and KREIS exams. Okay? All the best. Keep working hard. Bye.